Common network configuration concepts. We're going to start this lesson by kicking off talking about DNS. DNS is one of the most important and foundational protocols that we have on the internet. Now, DNS behind the scenes is resolving names of websites that we search for and translating them into corresponding IP addresses, a long string of numbers that no one is expected to remember. Now, if you type the IP address of a website into your browser, you'll come to the site that you're looking for. However, it's easier to remember a name like Amazon.com instead of having to remember 54.239.28.85. Now, in the early stages of the internet, this is what was actually happening. Today, there are currently 342 million registered domains, so keeping track of a list that long would be implausible. In 1983, DNS was developed, the Domain Name System, an automated, scalable system that handled domain name to IP address translation. The domain name system is also a distributed system across the internet that works to maintain robust performance when working to resolve IP addresses to domain names. Now, for example, if all the requests came from all over the world at the same time trying to find the domain google.com to an underlying IP address, and all those requests came into just one server, you can imagine what would happen. It would crash. So that's why the DNS system is kind of distributed throughout the internet. Also, there is a hierarchical structure to the DNS system. So let's look at that in a little bit more detail. Now, say for instance that you were a user and you were looking for the website cybrary.it. You type that into your browser, and that request is sent over to the DNS resolver. Now, the DNS resolver's job is to forward that request onto the root server. So it would send it over to the root server, and the root server is the root of the internet. Bottom line is, it knows where all the domains are in the structure. It knows where to point that request to. When you have a domain name like cybrary.it, google.com, there's actually a dot after that domain name. And that dot, that is the root or the utmost root of the directory. So the root server then responds and tells the DNS resolver to go to the .it TLD, which is the top level domain. Now, the TLD or top level domains handles all the domains like the .coms, .it, .net. So it knows across the internet where those domains or servers are actually located at. So the DNS resolver queries the TLD server, and the TLD server responds back, go to the cybrary.it name server. So it points the query to the cybrary.it name server. Okay, great. So now the DNS resolver knows where to go. It's going to the cybrary.it name server, and it's making the request of the name server. And the name server responds, yeah, I know where that website is. Here's the IP address. So it gives the IP address to the DNS resolver. So great. Now the DNS resolver knows where to go. It goes directly to the web server and it makes the request to the web server. I'm looking for the cybrary.it website. And the web server responds and gives the information and begins to render the web page on the client. And the client makes it to the cybrary.it website. And that's how a DNS query works. Now, that may seem like a lot of steps, but actually it happens in milliseconds. It is a very small amount of time, very robust system in how that works. So again, that's the overall view of a DNS query. So next we're going to look at is a DNS resource record. So, a DNS resource record is pretty much like a record in a database. It's like an entry in a database. Resource records are usually a name to an IP address, whether it be an IPv4 or an IPv6 mapping or vice versa. Their job is to map IP addresses to certain resources. So they act like pointers. Now, in the underlying workings of DNS, the name cybrary.it, as you see, will result to a certain IP address. But there's other resources and services that will point to IP addresses as well. So let's look at the first one. The first one is, of course, the probably most common one is the A record. The record or the address record, there's one of two kinds. There's either an A or a AAAA or a quad A. Now, an A record is used for IP addresses for host names or websites. So it defines the IP address to a host name or website. So again, it's the most common, most used. And again, IPv4 version is the A record, whereas the quad A is used for IPv6 records and IP addresses. The next record we're going to look at is a mail exchanger record. An MX record or mail exchange or mail exchanger record is a type of resource record in the domain name system. The MX record contains the host name of the computer that handles the emails for a domain, and it also has a prioritization code. Now, in this example that you see, it has different priorities. There's one or two ways you can set that up. We'll talk about here that in a moment. But the lower the value is the higher priority. So in some configurations, if you have a backup mail server, it will have a higher value to continue the processing of mail if the primary was to fall or fail. Or you can have the same value and it's meant as a load balance arrangement. So again, an MX record is actually a record that tells where the emails are held or being handled on a certain domain. Another value that you'll find is a text record. Now, a text record is short for a TXT record, rather, is short for text record. It's a type of resource record in the domain name system. It's used to provide the ability to associate arbitrary text with a host. Now, the text record was originally intended as a place for human readable notes. However, now it's used to put some machine readable information and data into that text record as well. So one domain can have many text records. So the most common uses for text records nowadays are email spam prevention and domain ownership verification. So, say for instance, if you've ever had to make changes to a domain, you can put a certain code that the provider gives you into your text record and you save that information, and that provider goes verify if that domain is yours. Because if it wasn't yours, of course, you wouldn't have access to it. But because you have access to it and you can make a change to that text record, it validates that you are the owner of that domain. Therefore, you can make the changes to that domain. Now we're going to look at some protocols and ways of preventing spam. The SPF protocol is a validated list of authorized email servers. So basically, this bounce up against a validated list of email servers to ensure that these are valid email servers sending mail. So it identifies the mail servers and domains that are allowed to send email on behalf of your domain. Receiving servers check the SPF record to verify the um, incoming messages that appear from your organization that are sent actually by you. So, of course, this is a way to check if emails are validly coming from you. And it also prevents mail spoofing, which means a mail server or service is pretending to be you and send email as you. So, this is a good check for that. Mail servers go through a relatively simple process when checking an SPF record. Server one sends an email, its IP address, its certain value, and other information, and the return path of that email uses is whatever the email address is in the domain. The mail server that is receiving the message, server two, takes that return path domain and searches for it in the SPF record. If server two finds an SPF record for the return paths domain, it searches the SPF record for the IP address and a list of authorized senders. And if the IP address is listed in that record, it the check passes and the email will go through. If the IP address is not listed in that record, of course it fails. In this case, it'll go through because it was found. And if it's not failed, it'll be rejected or marked as spam. So this is how an SPF record would look. If there's two IP addresses in that record down below, and if those two IP addresses would be validated to send information or emails out from that domain. Another record that you will come across is a domain keys identified mail. So basically, what this is an email authentication type record. It validates if it was sent by the sender, but it's a little bit more robust and it uses a digital signature, and also it's secured with encryption. So if the email is not found to be sent from you, it will be marked as spam. Now, this is can be used with the SPF records and with a DMARC, which we're going to talk about here in a little bit. So again, this is another step in spam prevention. So the domain-based message authentication reporting and conference DMARC prevents email spoofing. It validates, of course, incoming mail, and this is built on top of the DKIM. So there's options that happens when you have an unvalidated email. It can accept it. It can choose to you can choose to send it to spam or reject it. And it also has a feature for email reporting for compliance's sake. You can report that to a reporting server or reporting email address, and it can keep track of these emails coming in. Okay, DHCP, or most commonly known, Dynamic Host Configuration Protocol. DHCP, or Dynamic Host Configuration Protocol, is a network management protocol used to dynamically assign an internet protocol or an IP address to any device or node or on a network so they can communicate by using IP. DHCP automates and centrally manages these configurations rather than requiring the network administration to manually assign a static IP address to a device. It manages it and dynamically assigns the IP addresses to these devices. Now, DHCP can be implemented on small networks, large networks. This is one of those fundamental key configurations that you will come across on any size network. DHCP will assign a new IP address to each location when a device is moved. So if you unplug a device from a switch and plug it in somewhere else, it's going to give it an IP address no matter where you move it to within the network. So DHCP, or a Dynamic Host Protocol configuration protocol, has some management features with it. It manages the lease times, the reservations. We're going to talk about those in a little bit more. It also issues all the network requirements to the host. Basically, however you configure what's pushed out in that DHCP scope and reservation and other options, it gives that to clients when clients connect. It can be a very simple setup in your router or your firewall, or it can be very complex with a DHCP server or using a software. So the IP and network is delivered to the host in a process. The client makes an announcement, I need an IP address. The server reserves an IP address and makes a lease offer. The client responds with the request, and the server acknowledges that and sends the necessary information. And that necessary information we're going to talk about here in a little bit. So, um, needed information for configuring DHCP. Of course, when you're setting up a DHCP server or service, whether it's an appliance or a DHCP server, you need to define the IP address range. What's the lowest IP address range that it will hand out, and what's the highest IP address range that it will hand out? Also, you need to put in the subnet mask information and the lease duration. And we're going to talk about the lease a little bit in a little more detail, but basically, how long do you want that IP address to be held by that device? 24 hours, 72 hours, sometimes even less than 24 hours. It may be a certain number of hours. What's the lease duration? Now, information about the scope. Now, the scope is basically other configurations and information needed by the DHCP server. You may want to give that information as far as the DNS gateway so I can go out to the internet. The gateway information, this is how you route your traffic, and other gateway servers, like, say, for instance, VoIP. If it's a VoIP client, they will be needing the VoIP gateway. So you can put that information in the configuration. So this is defining the scope, the range of IP addresses, and the assignment leads to your client. It could be different subnets as well. You could have a DHCP that handles multiple subnets. All that information will be in your DHCP scope. Now, um, the scope of IP addresses will be a continuous pool of available IP addresses. So there wouldn't be any breaks of the IP address range. It'll be a continuous pool. So DHCP reservations are sometimes these are these are called IP address reservations or static mappings. These are IP addresses that a device would normally or always get when it connects to the internet. Even though it's not statically assigned, it's reserved for that particular device. Um, so it's identified by the client's MAC address. And when you configure this and you set it up, of course, you give it the IP address that you want it to always have and a description what that service is for. Now, let's talk about some different ways why this may be useful. Say, for instance, if you had a device that other devices needed to connect to obtain a resource or to view information, you always want that information static and doesn't change on the network. So you would do a reservation. You would reserve that IP address for that device. If this device was only a DHCP based device and could not be statically assigned, this is a great way to reserve that IP address for this particular this client. So when a client gets an IP address, we talked about the lease time. The lease is basically a temporary assignment of the IP addresses. The device actually is borrowing that IP address or renting it for a period of time. So the lease times vary. They can be expressed in seconds or hours, depending on the application that you're using. And this can be managed by the administrator. At any time, the administrator can go into like a control panel of some sort and view and see what IP addresses have been leased out to what devices. And they also have the option to pull that lease back if needed to. Another important concept that you'll come across on our networks are VLANs or virtual LANs. So this is a way of making network segmentation on your network. And there's one or two ways of doing this. You can do it by an 802.11q VLAN specification, which tags the switches, tags the device, the protocol, and the traffic in the switch and in your routers. Or there's a port based, which means there's a physical port that you plug a Ethernet cable in, and that's part of a VLAN. So let's look at this a little bit closer. So, say for instance, you had a network of switches, and you had VLANs 10 for accounting, 20 for administration, and 30 for HR. In a traditional environment, you wouldn't want one department's information being crossed with the other, so you would put them on a VLAN. This is a very cost-effective way of doing this. These, again, can be port-based or tag-based. If it's tag-based, you don't have to worry about configuring any ports. You build the VLAN information to your configuration, and it's the traffic is tagged. If you identify that certain devices are part of this VLAN, it will tag that traffic from that device and put it on its own VLAN, segregating it from the rest of the network. Or it could be port based, and it's isolates based on ports. VPN. A VPN is a virtual private network, and there are many ways of configuring VPNs and many uses for VPNs. A VPN, again, is your one device traversing through the internet private in its own space to another device. So there's no sharing of information. It's all secured and private. So basically, there's different ways you can configure VPNs. There's different types, rather. It could be a remote access, meaning I'm a user out in the internet and I need to connect to a branch office or a home office. I'll connect to a VPN to securely connect to that network. Or it can be a point to point where I have two offices that are connected via VPN point to point. Or there could be a type of dynamic VPN, like a DM VPN. And basically, that's a cloud VPN where I can connect one location to a cloud and access the resources there, and from the cloud to another location, and vice versa. So those are different type of VPN configurations. Sometimes these are software based, like an agent, or hardware, where it's a physical routers that's doing the concentration of the VPNs from a point to point. Okay, we have covered a lot of information in this lesson. We went over DNS and the most important areas of DNS. They're A records, a quad A records, MX, and text records. We talked about spam management, the DKIM, the SPF, and the DMARC. And also, we finished off talking about DHCP, leases, scopes, and reservations, um, VLANs, and also virtual private networks, VPNs. Thank you for joining this lesson, and I will see you in the next lesson.